Okay, so indicator 21 is solving quadratics, and in order to solve them, first you have to factor them, which is why we're kind of building on indicator 21. So there's a couple of things I want to address. We have done a lot of different factoring over the past, I don't know, month and a half. You've got to go back to all those tools in your toolbox. You have to think about factoring as kind of this toolbox, and there's a lot of different ways you can factor. And what happens is we come out of indicator 20 with the factor sum table, like in our laser focus, and then we get to 21 and it says solve by factoring, and we think that the factor sum table is all we got. And that'll throw you when you get to a few of these because it's not the only tool in your toolbox. So when you're talking about factoring, oh, you know what? I bet I didn't open it with Cami. I didn't. Can't really write on it if I don't open it with Cami. So in our factoring toolbox, things that we have talked about so far is the first thing we talked about was greatest common factor. So come on. There we go. All right, so you got to think about this kind of this factoring toolbox. And there's not too much in it, but you do have to remember, oops, that you've got a couple options. The first is greatest common factor. And you should think about this even if it's a trinomial that you look at and you think factor sum table, and I'm going to show you in one of our examples today. If you will think greatest common factor first, sometimes you will save yourself a whole lot of work, and I'll show you what I mean by that. But that should be the first thing you think of every single time you're asked to solve anything by factoring, is think, is there a greatest common factor? Okay. The second thing that we talked about was, of course, the factor sum table, and I'm just going to put FS table. Hopefully by now we've said it enough times. Okay, that's the factor sum table. And then also kind of within the quadratics, we also saw a difference of perfect squares. And I list that separately because you work it separately. I don't think I spelled that right. That's all right. That's why I teach math. So if you will remember that all of these are in your toolbox, okay, it's going to make completing this indicator 21 a whole lot simpler. So there's a couple things I want to steps, okay, because I know some people prefer to do it and some people prefer steps. So we're going to talk about steps. The very first step is to make sure that whatever you have in front of you is set equal to 0. And we'll do this in the examples here in a minute. But your equation, whatever that equation involves, needs to equal 0. And so that might require moving some things around, and we'll talk about that here in a minute. When you set it equal to 0, your equation has to be in descending order. You have to have the squared value first. So remember we had ax squared plus bx plus c equals 0. Okay, you have to have the squared value listed first. You have to have the single variable, okay, whether that's an x or an m or whatever. You have to have that in the middle, and then you have to have your numbers last and then equal to 0. If you put it out of order and you list the x first and then the x squared in the middle and then the number, when you go to do your arc for your factor sum table, the right numbers aren't going to line up, okay? So it's really important that you put it in that. And then from there, we kind of branch out, and there's two different, if it's two terms, okay, two terms in your equation, you're going to think, obviously, always greatest common factor. Think that first. And then you're going to look and see if it is a difference of perfect squares. Okay, greatest common factor and difference of perfect squares. And then you'll solve it from there, and I'll show you how. If it is three terms, still think greatest common factor first, because it might save you a whole lot of time. And then after that, your factor sum table. And I will wait. This is so important. I want everybody to have this right here down in your notes to refer back to. So I'll wait and make sure everybody's pencil has stopped so I know everybody has it. You good? Looking for pencils moving. All right, so taking all this into consideration, the first step is you got to make sure your equation is equal to 0. If it's not equal to 0, it doesn't work. And that's kind of goes back to what I told you in the jumpstart example. You have to have it set equal to 0, because if it's not set equal to 0, then it's not the zeros or the intercepts or the roots of your quadratic. So it has to be set equal to 0. And then it has to be in the right order. And then from there, you split off, is it 2 or 3 terms? So, I'm going to give you this first example, and I almost hesitate always every year. I hesitate to make this the first example because this usually throws people. What is our goal, or what was our goal of factoring? To get it from a quadratic to what? Yes. Yeah, a binomial times a binomial. Here, step 1 is done for you. They gave it to you as a binomial times a binomial. So it's just basically eliminating the whole step of looking at a quadratic, finding the winning factors, working all the problem, and then getting it to a binomial times a binomial. So when you see this, this is not harder. This is actually way easier. They did all the work for you. So all you have to do is take 2b minus 5 equals 0 and b minus 8 equals 0. You set your two factors, or your two factored sections, equal to 0, and then you solve both. So in this case, we're going to add 5 and add 5, and we get 2b equals 5, and then you divide by 2 and divide by 2, and you get b equals 5 halves. My handwriting is kind of atrocious today. And then you work them as two separate equations. So then we go over to the other one, and what do we need to do to get b by itself on this one? Well, we add 8 and we add 8. And so we get b equals 8. And so then our answer should be written as a solution set with the two values that x, or in this case b, can possibly be. Okay, so this is your answer right here, written as a set of answers that make this equation true. So either 5 halves or 8 is going to make this equation true. Okay, and I'm not going to do this on every one, but I just want to show you why it makes it true. I'm going to take the 8 because it's a whole lot easier. If I plug 8 into here, 8 minus 0 is 0. What's 0 times anything? Does it equal 0? Okay, if I plug 5 halves into the other one, I'm going to get a 0. And then when I take 0 times the other binomial, 0 times anything is 0. So either one of these is going to make our equation 0 equals 0. Okay? All right. Give you a minute to write this one down. So the first thing we look for is greatest common factor. There isn't a greatest common factor here. Oh, sorry. I was writing and talking. There is a greatest common factor here. Sorry. The first thing, there's two terms here, right? Two terms here. So that means we're not going to be doing a factor sum table. We're not going to be doing any of that. We have two terms, so we need to think greatest common factor and difference of perfect squares. And you kind of at the same time look for both, okay? This is definitely not a difference of perfect squares. 3 isn't perfect, 5 isn't perfect. So we know the only tool we have is greatest common factor. What do these both have in common? The 3s and 5s don't have anything in common. Yeah, they both have an x. So I am going to factor that x out front. This should be very familiar. We have been doing this for almost a month now. You pull the factored x out front, and then you reduce. Well, when I reduce this first term with the x, I'm left with 3 and then a single x, because this x1 takes one of those away. And then these two x's cancel out or reduce to 1, so it leaves me with just minus 5 equals 0. And then you set everything equal to 0. And that's okay that there isn't, if it makes you feel better, you can do this. You don't need to do that, okay? Not necessary, but you just set both equal to 0. Whatever you factored out and whatever's inside the parentheses. So x equals 0. That's one of the parts set equal to 0. And then on the other one, can you take that out, please? The other one, you've got 3x minus 5 equals 0. Now the x equals 0, bonus score, it's already solved for you. You don't have to do anything. It's just x equals 0. And on the other one, you have to add 5 and add 5. And that gives you 3x equals positive 5, not a minus 5. And then you divide by 3 and divide by 3, and you get x equals 5/3. Don't let fractions mess with you here. Just leave it as a fraction. And then again, your final step is to put this in a solution set. So 0 and 5/3 are the two solutions to this. Okay? So when we see two terms, we immediately need to think greatest common factor and difference of perfect squares. Yes? If it specifically, you should get in the habit of writing the smallest one first. Would I count it wrong on a quiz or a test? I wouldn't. But if Khan Academy specifically says what's the least answer and what's the most answer, then you would put 0 for the least and 5/3 for the most. So, but as far as like me, as far as counting it wrong on a paper pencil quiz test kind of thing, I wouldn't count it wrong, but it's just a good habit to get into, to write them in order of least to greatest. Good question. All right, so let's look at this example. Now, for this one, it's 3 terms, right? So we're going to be kind of in that 3-term column. And the first thing to look for is a greatest common factor. We don't have one here. There's a 1 out front of that V. So that right there tells you you're not going to have a number that's a greatest common factor. They don't all have a V. So we are ready for the factor sum table. Factors have to equal the arch. Okay, 1 times negative 30 is negative 30. And they need to add up to that center number. And it's not there, but it's there. What's our center number? Negative 1, good. Okay, anytime it's in front of a variable that there's nothing there, it's really a 1. So I need 2 terms that add up to negative 1 that multiply to give me 30. I know that 5 and 6 are 1 apart. So which one am I going to make negative, the 5 or the 6? The 6. I have to make one of them negative because I need my factor to be a negative 30. And the only way to multiply and get a negative is 1 positive and 1 negative. And then if I test my theory over here, 5 minus 6 is in fact negative 1. So my winning factors are 5 and negative 6. Now, this one has a 1 out front. So I can skip all that work that goes in the middle of factor by grouping, right? And I can go right to my binomial answer of the factoring part. So I'm going to put V plus 5 and V minus 6, right? I was able to go right from my winning factors to my binomials. And since this indicator is solving, we have to do that last step of setting both equal to 0. So V plus 5 equals 0 and V minus 6 equals 0. And then we solve both. So I subtract 5 from both sides and I get V equals negative 5. I add 6 to both sides and I get V equals 6. So my solution set is negative 5, 6. All right, so now let's write this one down just as it is, and then we'll talk about that first step that we have to look at. So this one is not set equal to 0. So we need to get it set equal to 0 by moving that negative 49x off of the right-hand side. Since it's a negative, I'm going to do a positive 49x. And then on this side, I'm going to write positive 49x. And this is the part that gets it's really important here. You got to stick that 49x in the right spot, right? You want your 14x squared to be first. So I'm going to write that first. Then you want your single x value next. So I'm going to plug that plus 49x right there in the middle. And then that plus 42 just stays where it was at the end, equals 0. Okay? Now, 14 times 42, that's a pretty big number. Okay? I wouldn't want to do a factor sum table with that big of a number. But if you'll think greatest common factor first, you might make life a little bit easier. Do 14, 49, and 42 have a number in common that I can factor out? A 7. So I'm going to divide each one of these by a 7. I'm going to factor a 7 out. Okay, it's just going to make my life a little bit easier. And when I factor a 7 out, 14 divided by 7 is 2. My x's don't change, so it's going to still be x squared. 47 divided by 7 is positive 7x, and 42 divided by 7 is positive 6. Now, I'm going to ignore that 7 right now, okay? I don't need it. But now I'm set equal to 0. I factored out the greatest common factor, and now my factor sum table doesn't quite seem so huge because 2 times 6 is 12, and 7 is my center number. Those are way better than what you would have got if you would have multiplied 14 times 42, right? I would much rather deal with this. This is pretty straightforward. My answer here is 3 times 4. How easy was that, right? Way easier than looking for factors and sums of those bigger numbers. And that's where I said, if you look for the greatest common factor first, you just might save yourself some mental work. Okay, you'll still get the same answer. You're just going to save yourself a little bit of mental power. All right, so 3 and 4 are my winning factors, but I've got to do it the hard way because that 2 out front tells me that I've got to kind of work. Now, for right now, I'm just going to take this 7 and I'm just going to drop it down here, and I'm going to forget about it for a minute, all right? Because I don't need it right now while I'm doing my factor by grouping, and it kind of gets in the way. So for right now, I'm not going to write that 7. I'm just going to worry about my 2x squared, my 2 winning factors, which were positive 4x and positive 3x plus 6 equals 0. Okay, so I've rewritten my quadratic. I've split out my 7x into 4x and 3x. Now we know to do the factor by grouping, and I'm going to divide by 2x here. I'm going to pull that 2x out front, leaving behind x plus 2. And if I do it right over here, I'm going to have x plus 2. So what would I factor out of this second one? Plus 3, right? Make sure you bring your sign with it. I'm bringing out a plus 3. So plus 3. And now, even with my 7 here, I'm just going to do what I would normally do. I'm going to put my 2x plus 3 and my x plus 2, right? Now, do you remember yesterday when I said factoring is like taking apart a Lego car? All the pieces are still there. If I ask you to put it back together, you could put it back together and all the pieces are there. That's why that 7 doesn't go away. That's why we bring it down, but I just keep it out of the way for a while because when you're doing all that factor by grouping, you've got so many numbers that 7 can just kind of clutter up the area. Okay, that's why I just kind of move it down at the beginning. All right, so now all my pieces are still there. The 7 I factored out is still there. The 2x plus 3 and the x plus 2. If I FOIL those, I would get back and I would get all the way back to my beginning. So now comes the step of solving, and you don't do it any different. You take every single term. 7 equals 0. 2x plus 3 equals 0. And x plus 2 equals 0. That's all my terms set equal to 0. Does 7 equal 0? Can I ever make 7 equal 0? So that one is thrown out. It's an extraneous solution. It doesn't work. Okay, we throw that one out. So now we just solve the other two just like normal. Minus 3 gives us 2x equals negative 3. Divide by 2 and divide by 2. And we get x equals negative 3 halves. And then on the other side, minus 2 and minus 2 gives us x equals negative 2. And then when I write them, if I write them in order of least to greatest, -2 is smaller than -1/2 because 3/2 is 1/2. So that's how you can kind of figure out whether or not which one to write first. Like I said, for me, I would never count it wrong if you put -3/2 first. But Khan Academy, if they ask for the biggest and the smallest, you're going to want to know how to do your negatives. Okay, -2 is a smaller number than -1/2. All right, let's see, just a couple more examples. I think I'm going to skip that one. So I'm not going to work this one all the way. Well, yeah, let's just. I won't even work this one all the way through. I just want to show you something. This is a big old quadratic that I would not want to factor 6 times 60 and finding all of that. But what can I factor out of here? If I factor out a 6, look how easy this turns into. I factored out a 6. I'm left with a nice, simple 1 in front. If I factor out that 6, I'm left with one of the basic quadratics that doesn't even require factor by grouping. I find my winning factors, and I go right to the answer. My winning factors here would be 5 and 2, and the 5 would be negative. So -5, +2. I literally took a giant problem that would have taken 5 minutes to solve, and just by factoring out the greatest common factor, I saved myself all that work, and I got myself a nice basic quadratic. So when you can, that's why looking for greatest common factor helps you. For this one, I just want to show you you're not always going to have a greatest common factor. Again, I'm not going to work this one all the way through just because of time. I want to give you some time in class to work on your homework. But we got to do a lot of moving here. So you might want to write this down, just the first part of the example. Like I said, I'm not going to work it all the way through to the solution. But there's a lot to move here, and it's important that you move it the right way. So I'm going to add 14, and I'm going to subtract 31 in from that side, right? Because I want to get both of them moved. So that means over here, I'm going to add 14, and I'm going to subtract 31 in. So when you write your equal sign, over here, 0 and 0, that's what we wanted. On the right or on the left-hand side, you've got 3 terms over there. 2 of them we just moved over. 1 of them was already there. You got to write them in the right order. It has to be 15n squared minus 31n plus 14, right? The -31, the negative stays with the 31. The +14, the positive stays with the 14. But you have to write them in that right order. If you don't, then your arc is not going to work. Now here, you've got 15, 31, and 14. Unfortunately, no greatest common factor. So this would be one instance where you're just going to have to deal with the really big numbers, okay? Again, I'm not going to work it all the way through because I think we've done that enough in indicator 20, but I wanted to really stress setting it up right by moving everything over and putting it in the right order, and then looking for that greatest common factor. Let's see, what else? I think I had one more example. Yeah, here's another example where a greatest common factor isn't there, okay? So luckily it's kind of an easy one, but you'd still do your arc of 3 times -7, which would be -21. And if you just want to watch this one, you don't necessarily have to write this one down. There's nothing special about this one, okay? But there's no greatest common factor, so you do have to deal with it. It's not hard, right? You can do -1 times 20. Nope, that didn't work. I did it the wrong. I put a 20. There you go. Helps if I write the right number there. There we go. I knew it worked out, but I couldn't figure out why it wasn't. I was doing my answer too soon. -1 plus 21 equals +20. And so there's your factors. You'd put them in the middle. Okay. Do the whole factor by grouping thing. So sometimes the greatest common factor is going to help you make it easier. Sometimes, like this one, it's not. Now, the last thing I want to show you, and this is just as a reminder, if you have something like 36m squared minus 16, okay, this is a 2-term one. So you got to think greatest common factor and difference of perfect squares. If it's already a difference of perfect squares, don't worry about factoring anything out. You'll just make the problem harder, right? So if it's a difference of perfect squares, we go right to, this is 6m and 6m, and this is 4 and 4. And we know with a difference of perfect squares, one has to be positive, one has to be negative, and now you're ready to set it equal to 0 and solve. Okay, so if it's a difference of perfect squares, those are great. Those are some of the easiest ones to do. So don't worry about, I could have factored out a 4 and then I would have had a smaller difference of perfect squares. You don't need to worry about that. Okay, just kind of leave it at this. All right. Okay, let me give you your homework assignment. I wanted to make sure you had about 15 minutes of class to get started on it. The original assignment had 20. I thought that was ridiculous, so I printed off a new one and cut it down to 10. Some of them are easier. There's a few that you're going to have to do some of the harder factor sum tables, but I made sure there was only a couple of those on the whole paper. All right? If you get done, I have a key up here that you can check your answers with the key. I think these are fun, and I wouldn't want to work 20 of them, so. Yeah, I'll walk that back since you got a gap in your row. Perfect here, perfect here. I have these 3 perfect. Wow. If you have any questions or if you get stuck, please don't hesitate to throw a hand up or holler my name, and I'll come back and help you happily. Who else was absent yesterday? We need to talk about when you're going to make up your exam. I think probably Friday would be the best day. I won't be here Friday, and whatever you have Friday can be done over the weekend, so I think Friday would be a good day, okay? Here's the key sitting right up here on my desk if anybody needs it. All right, for those of you at home, go ahead and hit load, pull up the assignment on Cami, and then make sure you show all your work. And if you have any questions, shoot me an email.